thing in this lesson. It will just be the factoring by the GCF without grouping, okay? So just as 6 can be factored to 6 times 1, if I said to you, show me all the different ways to factor 6 times 1, you could say, well, you can take 6 times 1, or you can take 3 times 2, or you could take 3 times 2 times 1. So, polynomials can be factored also. Not all of them, but we want to always check to see if they can be factored. So the steps to factoring polynomials by the GCF. What does GCF stand for?
Greatest common factor.
Greatest common factor. So we're going to factor each term. That's going to be our first step. And find the GCF of the terms. So we're going to look at those terms together, whether there's 2 of them, 3 of them, 4 of them, however many there are. We're going to see what's the GCF of all of those terms acting together. And then we're going to divide each term by that GCF. Because what we're doing is we're unmultiplying, really. We learned how to multiply polynomials. Now we're learning how to get it back to the state it was in before we multiplied it out. So we'll divide each term by the GCF. And then our final answer will be, when we write it, this is what is called writing it in factored form. In fact, will you put that here? We will write it in factored form somewhere. Fine room. I don't know if you have that white space over there, maybe not. When we write the GCF as a factor and the resulting terms after our dividing step as the other factor, we're writing that polynomial in factored form in its state before it was actually multiplied out. Okay? So we may be probably even practicing some of the same ones you did in your SQ3R here. So the first one, 9b cubed plus 5b. Step 1, factor each of them till they are prime factors and all of the variable parts are even shown factors. So 9b cubed. So first thing we'll do is we'll write it down here and then we'll do the 5b on the next line. Let's factor these up. What are the prime factors of 9? And you get to leave out 1, by the way. 1 is really not a prime number. It's 3 times 3, okay? And then we will write b cubed as b times, as its factors. B cubed is the shortcut way of writing it. It really means b times b times b. And then 5b can be written as 5 times b. Yeah, that's as good as that one's going to get. 5 times b. Now, whatever factors they have in common are going to become the GCF. So in this one, they each have a factor of b. Do they have anything else in common? No. They both have to have it, whatever it is, the factor that we talk about. So we are going to say here that the GCF is b. That's our GCF. Okay, now in step 2, it says divide each term by that GCF. So, oops, I have that wrong. So we're going to take that 9b cubed, and we're going to show division as a fraction. And this had a plus sign between it. And we'll take the 5b and divide that by b. The b is not going away, by the way. The b is going to be right down here in our factored form answer. It's one of our factors. It's one of our factors, and we're trying to figure out the other factor right now. Now, in our notes, I want you to see how this started. I want you to write that again, please. Just write it again. Just humor me. And we'll do our work in that one, okay? Because we know how to divide, right? We did this with powers already. There's nothing to divide into that 9, but this b can go into itself, right? And then b cubed will become what?
B squared.
B squared. This b can go into itself, and it can go into itself up there. So we really have 5 times 1 upstairs, right? Okay. Or you can just say, you know what, they just cancel out. It's totally cool too. And now we can say, oh, the result is, what do we have for this first term? 9b squared plus 5. So there's our other factor. 9. 9b squared plus 5. Now how do we know if we have a good answer? It would multiply back out to get what we started with. So if we took that b, that monomial b, times that binomial 9b squared plus 5, it better get us back to 9b cubed plus 5b. How are you feeling about that? Think it would? We did the distributive part, we did the actual multiplying. Yeah. Okay. So I want you to write on your notes right here that this is what we call factored form. So they ask you to write a polynomial factored or in factored form. That's what they're asking you for. And this is a really, really critical skill to know how to do. It's used a lot. Okay? Anybody got questions? Okay, then by the way, let's take a little look here at something. You know, when we did this dividing here in this step, we did this dividing, and then we did another division here, and notice what we got. We got this 9b squared, and we got this 5, right? Look it up here. After we take that b out of there, we have a 9b squared left, don't we? After we take that b out of this one, we have a 5 left. So in reality, same thing, right? We're dividing out, we're saying, I'm going to divide a b out of both of them. That's this right here. And this is what's left after I do. Okay? So let's try that with 15a squared minus 5a. By the way, don't worry about changing subtraction to add the opposite of these. Just leave them. In fact, it'll probably work better for you if you don't. Okay? So step A says, take each of those terms. Don't worry about the subtraction right now. Take each of those terms and factor them out. So 15a squared, what do you want me to factor that to? Jade?
5 times 5 times 5 times a times a.
5 times 5 times 5. Careful, I think you're thinking of adding. How many 5s did you just do? Okay. 5 times 3, right? Times a times a. Yeah, 5 times 3 times a times a. 5 times 5 times 5 would have been 125.
Yeah, I realized that after I said it.
And then 5a, 5 times a, right? Okay. So let's determine our GCF. Well, they both have a 5 in common. They both have an a in common. That's as good as it gets though, isn't it? So what's our GCF?
5a.
5a. So, right away you can go down here and say, I know what one of my factors is, it's 5a. Because you know what students tend to do? They tend to forget about that one that got divided out. Because now we're going to divide that out. We're going to take 15a squared divided by 5a minus 5a divided by 5a. And it's good to have notes that are clean, so that we can see what we did. So I'm going to do it again. And I'm going to show my division there. Okay, 5 goes into 15. How many times? 3. A goes into a squared. What's left? Just an a, right? 5 goes into 5. A goes into a. Does that mean that term is done? It's just a 1, yeah. This becomes a 1 here. Don't think that it's none. It's not 0. Something divided by itself is 1. So we're gonna say that we now have, what's our other factor? 3a
Minus 1.
minus 1. Now, if the GCF you use doesn't eliminate the denominator, you're in trouble. You should not have fractions in that. I mean, in reality, you should not have fractions in this factor here. So now we would say 3a subtract 1 is our other factor. And then I want you to move it down here, and I actually want you to multiply it out as if we had not done that. Let's pretend we're still back in chapter 6 and you're multiplying. Did you multiply that the way you multiplied it back in chapter 6? Multiply that out just like we did in chapter 6. You can use distributive property, rectangle, vertical, horizontal. What does it become?
2a squared minus 5a.
Yeah, is that what we wanted it to become? Absolutely we did, yeah. Okay. So whatever we get better be our, so what are we going to call that? Factored form. Yeah. Get used to that, because if they ask you that on a test and they say, write the factored form for this polynomial, you gotta know what they're asking you to do. What are they asking for? Okay, is there any questions on it? Okay, we're going to try a couple of others on the back side here. I want to make sure that you understand what to do. Well, first of all, when we have more than 2 terms, how do we find the GCF of that? Is it going to be any different, do you think?
No,
No, but what's going to have to hold true?
it's gonna have to be, they all have to have the same root. or
All
factor.
3 of them have to have the factor in common now, don't they? So let's just get those factored. Go ahead, you know how to do this, right? Don't worry about that subtraction. Just factor each of those terms. Okay, what's one factor they have in common? A 2, okay. All 3 of them have one factor of 2, okay. Are there any other factors they have in common? All 3 of them have a factor of h. Any others? All 3 of them have to have it, don't they? Yeah, so a couple of them have a couple of them have something in common, but then the third one's missing it. So what's our GCF?
2h.
2h. So we already know down here that we're going to have a 2h times a trinomial. So here's how we're going to do it this time. We're going to show 12h to the 4th divided by 2h plus 8h squared divided by 2h minus 6h divided by 2h. Now we can either do the division the way we were on the front, or we can shortcut this and say, you know what, we've done a bunch of work up there already. Why don't we just do this? Say, I got 2 times 3 and h times h times h. What's that?
6h.
6h
Cubed.
cubed. In my next one, I got 2 times 2 left in an h. What's that?
4h.
4h.
Minus
What's left in this one?
3.
A 3. So our other factor is 6h cubed plus 4h minus 3. So questions or concerns about that one? Okay. One more, because this one can get confusing. When a leading coefficient is a negative number, sometimes we don't know what to do when we're factoring. Okay, so here's what's the best thing to do. Take that this is a leading coefficient because it is in standard form. So what is our leading coefficient?
Negative 5.
-5. So when the leading coefficient is a negative number, you will have better success if you just take out a -1. In other words, you put a -1 out front. It's kind of like you're dividing each thing by -1. Or in other words, you're changing both of these to their opposites. So if I divided -5 by -1, what would I get?
5.
Positive 5.
Negative 15.
And if I divided 15 by -1, I'd get -15. We don't care if the other terms following it are negative. That's okay. We just don't want the first one to be negative. Because here's what we're going to do now. We're going to rewrite that cleaned up. And we're going to rewrite that cleaned up, and we're going to work with what's in those parentheses. But here's what I want you to do. I want you to put an arrow bringing this down so we don't forget about it, because it's not gone. It's still a factor. In the end, we're going to deal with it. So for right now, we're going to do our step A, which says factor each of these terms. Remember, we don't worry about that subtraction there. So we factor each of those terms. Because we're looking for the GCF. And it appears our GCF is what? 5G
squared.
squared. Yeah, doesn't have to be just to the first power. It can be a higher power than that. So it's 5G squared, we can both have 2 G's in common. G times G is G squared. So now we say, oh, step B, actually each of these is divided by that. And it's minus right now. Each of them is divided by our GCF. We haven't forgotten about that -1. It's coming back to us later. Well, when we divide this out, I'm just going to look up here and see I have a G left, right? And I have a 3 left. See where those are coming from? G and 3. So now I'm ready to, in step C, here we are to step C. And we're ready to say, this guy, I made my arrow a little bit too long, I'm going to shorten it up here. I'm going to bring it back up here, I'm going to say this has got to come right down here to this step C. I have a -1. I have a greatest common factor of 5G squared. And I have my other resulting factor after my division of G minus 3. Now we're going to clean that up a little bit. We're going to take that -1 times that 5G squared. So our final answer is going to be -5G squared times G minus 3. There's our factored form. Now, if we hadn't taken that -1 out, it would have made it trickier for that. That's all. That's why I read it over. It usually helps. Question?